Okay. Good morning. Welcome back. We're going to finish chapter 27 on hashing. Before I go to hashing, I like to get this programming project for chapter 26. Now, this programming project for chapter 26 is due tonight. Do you have any questions? Any questions? All right. Just to remind you that you can look at the hint. So there's a hint page here. So this is the hint. So you can look at the hint. So here's the hint page. So here's the hint page right here. So there's a hint already given to you right here. Okay. So if you still have questions, please email me, let me know. And all right, any questions for now? All right, so let's move on now to finish chapter 27 on hashing today. We started to implement hashing in the preceding lecture. So let's go to this implementation for hashing. So the one we looked at it last time is to implement my hash map. So this is the my hash map interface. So this is my hash map. So this is the my map interface, and this is my hash map concrete class. So here, and we design it to mirror the Java API. So this is very, very similar to Java API and all these methods and the name of the methods, and they are almost identical and to the Java API. So we have this, my hash map. This is the constructors, and all these methods are defined in the interface. And we have this, the entry defined in the, this is the my map interface. So we define this is entry. So this is used in the methods here. So we look at the entry here. So we get the entry. So, all right, so the implementation. So here's the interface. And this is the concrete class, my hash map. My hash map implements my map, implements my map. All right, so the very important thing is about this is the table. And so how do we define this hash table? And we did it the other day in the class, so we explain it. And this is the it's using array. Each element in the array is a linked list. So it's like this, linked list. All right. And this, what is the elements in the linked list? It is my map dot entry key and value, and this is the brackets here. This is array. So if you don't have this is the brackets, it's just becoming a single linked list. But this is array of linked list, and each element in the linked list is an entry. All right, so when you implement this, look at this diagram. This would be helpful. And let's look at this diagram here. And this is the diagram for this linked list. Used as buckets. And so here's the linked list used as buckets in the separate chaining. All right, so here, this is the all this buckets, okay, and this is one bucket. It's a linked list. So this is the and in the linked list is entry. So here in the visual diagram, we just have this the key and the value is not displayed here. All right, so this is the one. Okay, let's go back here and look at this. And now we also explained the load factor threshold. So this is the here is when you create a hash map, you can specify the initial capacity for the hash table and also the load factor threshold. So look, this initial capacity, it's just the starting point for the hash table size. The size is going to be automatically increased when you have more elements in, and that exceeds, and the threshold factor exceeds the load factor, the percentage exceeds the limit, this threshold. So then this is going to be automatically increased. The size is going to be doubled. It's internally, and that's managed. It's just like when we implement array list. So for the array list, you actually also can specify the default capacity, but that capacity is just as initial reference. And later on, if you increase the list size, and internally it is automatically expanded. And the expansion is you're going to create a new array with a larger size and copy the existing one to the new one and discard the existing one, the new one becoming the existing one. So it's the same thing here. We're going to see it when you look at, I'm going to look at this method here. Let's do this add. So here's the add method. In hash map, the add is called a put. So this is put. So put this key and value. So what do we do this? All right, so here. So we first look at, this is the key is already in the hash table, and then we do nothing. We're not going to do anything. So if it's already in, if the okay, so this is put. So if it's already in, now we are going to replace it. So if this key is already in the table, we're not going to add a new entry, but what we're going to do is to replace the existing entry with the same key with a new value. So this is, it's right here. You're going to see if this is false. So we jump to here, and this is the here, and we jump here. All right. So we jump to this. We jump to this. Oh, sorry. All right, we jump to this. This is actually this code is not needed for this case. If this is the it's already in, so it's not, this is not going to be an issue here. The size, it's yeah, this is the one. I think there's some room to improve this code is here. So here is the size is greater than or equal to this capacity times load factor threshold. So this is going to be exceeding the size, the capacity. If the capacity is equal to this max capacity, then we're going to, this is exceeding this maximum capacity. Otherwise, we're going to do performing a rehashing. So here is this is going to look at this rehash. So there's a method is rehash. So this is rehash. What you're going to do is you're going to see this is the, we're going to create a new linked list here with more capacity. So this is double capacity. Original capacity is this. And now with this is you're going to do this is shift one position to the left. So that's 2 times. And it's bitwise operator. And then assign it. So this is the capacity is doubled. And the table size is now, new table is doubled. And so we're going to just copy everything, just rehash everything into this new table here. So you can write the code here is it's something like this here. It's you're going to do a put. So here it's going to be put this entry dot key entry dot value. So put it back into the table. So here's a hash, rehash. All right. So if necessary, we need to do rehash. If not, if the size is still good, we don't have to do rehash. So now we get the bucket index, and from this hash function, and we get the key dot hash code, and this is from Java here. For every object, we have this hash code, and here's the hash, and to get the bucket index. So here is table. This here brackets bucket index. If it's null, so that means we need to create this linked list for this entry in the table. All right, so after this, we're going to add this entry, this new entry into this bucket. So this is the bucket. It's a linked list in this hash table. And so now you're going to increase the size and size plus and return the value. And the value just put. So this is the value. All right. So now if this is the if this is not in the table, so we're going to have this bucket here, and then we get this the bucket. All right, from this table bucket index. And now for each of this entry, so we're going to see if this is equal. Okay. All right, see if this is equal. Entry dot get key is equal to the key. So if it is, we're going to replace the value here. Just simply replace the value. The old value is replaced by new value. And so this is going to return the new value. So this is the entry value. So you get this. You're going to retain the old value. So you're going to return the old value. The entry dot value is going to be replaced. So if it's not null, it means it's already there. So this is here. All right. So I guess I'm going to let you to study and digest the code. And this is for the implementation of my hash map. Next, let's look at the implementation of my hash set. So we're going to design it very similar to the Java API for this my hash set. So what I'm going to do is this, is make my hash set a subtype of collection. All right, so here's the constructors, all right, and all the methods are coming from the collection interface. So you have all of these methods there. All right, so we're going to write the code to implement it. So this is my hash set, it's going to implement this is collection interface. So this is the collection interface. In this, my set, and you just have this entire object. You're going to have this object and put it into the hash set. You have many of objects. You put all the objects into the hash set. All right, the default initial capacity, so this is 4, and the max capacity is 2's power raised to 30. And here, and this is the data field capacity, and this is default max load factor, 75%. All right. So we just use the one like in the Java API. So this is the using a floating point for this 0.75. That's what Java API use. Okay, and this the number of elements in the set. So that is the size, and initially is 0. And this is, how do we write this here? The table, hash table. So hash table, it's a linked list. All right. So, but now, what are the elements in type in the linked list? So the elements type here in the linked list is what? Okay. Okay. The type, this is going to be E. So the E. So please recall that when we have the hash map. So this is what we have. It's hash map dot entry and key and value. Key and value. But now, and this is all we have, is just the element itself. All right, so the constructors are very similar to my hash map. So here's for my hash set. So this is the constructors here. And all right, so let's look at this. Contains. How do you implement contains? So here we have this object E, and we're gonna get this hash code here is a hash function. So E dot hash code, okay? E dot hash code, okay? And then hash it, apply the hash function and get the bucket index. So here, table brackets bucket index, if it's not null, all right, if it's not null, means there is a bucket already there. If it's null, that means no bucket. So that's going to be definitely going to return false. It's not there. All right. So if it is not null, all right, we'll get the bucket. So the bucket is, it's this. So what is this table brackets? All right, bucket index. So that's the one here. All right, we have this bucket, and now we're going to apply this method from the bucket is a linked list. So return bucket that contains E. So it's true or false, and that determines whether this element is in the hash set. All right, we also implement this add. So here, the add method is override. So add method is defined in the collection interface. So we implement it. So add contains E. If it's already contain E, and so here is we have the contains E. It's like this that contains E is the set already contains E. So returns false. You cannot add it because the sets are the elements are not duplicate. So all distinct. All right. Else we're gonna insert it. So check the capacity and the capacity. And so this is the same way we did before the capacity. And so if we need to increase the capacity, so this is, we do a rehash here, right here. It's a rehash. So let's do a rehash. And this is the, all right, so now we're gonna add it. So we get this bucket index. So if it's null, we have to create a new bucket. So this is where we create a new bucket, and now we add this E into this bucket and increase the size for the set and return true. All right, so this is add, and you can look at remove. How we do remove is empty, and now iterator. Yes, we have to implement the iterator because this collection interface is a subtype of iterable. That's, you're going to have iterator. So how do we do the iterator? So this is, we're going to do the iterator. This is going to be iterator. You're going to return an iterator, return something. So return what? This is the one here we're going to have. We're going to copy and paste it here. It's new hash set iterator. All right, so this one going to implement the iterator. So look at how we implement the iterator ourselves. So we're going to have get all the elements and into a list. So here's a array list, and then we have the cursor, the pointer, for this current, and then go to next. So this is how we're going to implement. All right, so this is the all this code, and so please study and digest it. Okay. All right. So here's all the detailed discussion, and so you can read this, everything here, and then do this. Look at the time complexity for all these methods. For this, contains, add, remove, is empty, and size, and all this method is order of one, the constant time, and the method clear. So that's the time is the capacity of the table capacity. A rehash is this order of the capacity, and iterator, it's the order of the capacity. So we do this rehash, it's very less frequently. So this is it's most of the time you just keep adding things, keep adding and removing things. You don't have to do any rehash. So and so the overall performance and is very good. It's all of one time for all this the methods. So I think we have we should have more methods. Yeah, contains. So this is the contains is like to do a search, add is to insert, right? And the remove is to delete. So this all these methods are all at one time. Okay. So here's the example to write the test code. So we have this my hash set. So this is, you can do a hash set, you can add. So add a new string. So this is the pares here. So here's the this is the string. So this is the set. Look, this set is a subtype of collection. So you can have my hash list. So creating a hash list for this. So you can test it and return the size, and you can use the contains. So here the set dot contains. So contains what? Contains the this string is pares here. You can remove pares, and so names in set in uppercases are, so you're gonna do using the iterator. So the iterator here. So all this and clear it, and then look at the set, it should be empty. So this empty is empty after you clear everything. So this is just test code and for this implementation of my hash set. All right, so let's look at the programming project for this chapter. We have two programming projects. So let's look at first one. First one, you're going to implement my map using open addressing with linear probing. In the book, we implemented my map using separate chaining. So now you use this linear probing. You don't have to write the complete code. I have this template for you. So if you look at the template here, so let's go to the template. So this is the template. So you're going to see there's a test code and study the test code. All right. So here is a copy from the book, entire interface, my map. So this is my hash map. So look and see how we're going to do this. All this, I already gave you most of the code. All right. For this, you need to go to digest it, see how linear probing is done. And then we go and to finally write your own code is write only these two parts here. It's get and put, implement get and put. Okay. Okay. All right, so this is the one right here.
By the way, for the second
Yeah.
programming assignment, for chapter 27,
Yeah.
I can't find it in the hints. Like, when you click on it, it just says this page doesn't exist.
Okay. You mean this one right here? The
Yeah,
template? Okay.
template you can find, but it's like when you go down to the hint at the
Oh, the
bottom,
hint,
yeah,
hint about. Okay.
it just says the page doesn't exist.
I think maybe yes. It's right. It's a typo here. Okay, it should be this. The hint is this. Okay, the hint is Java 13E. So yeah, that was a mistake here. Thank you. So we're gonna fix this. Okay, it's Java 13E. The hint is just like all the other hints. So this is the wrong link. Yeah. Okay. Thank you.
I couldn't find it in the list because when you scroll down to chapter 27, there's only one of them.
One of them. Okay. So we're gonna also need to fix that chapter 27 for this. Okay. Okay. So I got it. Thank you. Okay. All right. That's very good. I need to fix that too. Okay. All right. So for this, this one here is you're gonna write the code and to implement set operations in my hash set. So the implementations of the methods add or remove or return or to array and to array. This is another to array emitted in my hash set. So we're going to write the code to implement it. So let's see if we have it. The template is here. All right, so the template is here. So this is everything here. All right, so we need to write the code for this. Okay. Yeah. And write the code. Okay. Okay. All right. I'm going to let you study this chapter and study this two program projects. And when we meet next week, we can talk about this. Let's look at the due dates, and the due dates is should be a week from today. I think it's let's see what. So it's going to be due 27th. Yeah. So we have plenty of time. So but I want you to go ahead to study it, to look into this, see how we implement it. And so you first need to understand the overall the techniques for linear probing, and with a visual diagram, and then look into the code, and then to write your own code. Any questions? All right. If you have questions, you can stay, and have a good weekend. Goodbye.
I had a question about the exam 2 date. You posted on Folio that was November 30th, but that's
Yes.
not
Right.
a Monday.
Mhm.
I
Yeah,
think so.
exam. It's we have the exam. It's going to be Monday, November 30th, right?
October 30th.
Thursday.
Oh, I'm sorry, October 30th. Yeah. Oh,
Okay.
okay. So I got it. That's wrong. Okay. I'll fix that.
Okay.
Okay, thank you. Okay, I'm
Yes,
gonna
sir.
check on that. Fix it. Okay, thanks. Yeah, it's gonna be this month, 30th. Yeah. So this is going to be, yes. Okay. And 30th of October. Okay. All right, thanks. Okay.
Yes, sir. Have a great day.
All right, thanks. Bye.